ಈಗ ಸರ್ ಇದು ಮಾಡಿ ಸರ್
ಕ್ಲೋಸ್
ಇದು ಕ್ಲೋಸ್ ಅಲ್ಲಿ ಈ ಸ್ಟೆಪ್ಸೇ ಭಾಳ ಇದೆ ಸರ್ ಇಲ್ಲಿ ವ್ಯೂ ಸ್ಟ್ರೀಮ್ ಒಂದು
ಸೆಕೆಂಡ್ ಲಾಸ್ಟ್
ಕಾಪಿ ಸ್ಟ್ರೀಮ್
ಇದು ಪೇಸ್ಟ್
ಎಂಟು ಮಾಡಿ ಸರ್ ಇಲ್ಲಿ ಲೈವ್ ಕೊಟ್ಟಿರ್ಬೋದಲ್ಲ ಸರ್
ಲೈವ್ ಆಗಿದೆ ಸರ್
ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕಲ್ಲ ಹಾಂ ಫೈನ್ ಸರ್ ಲಿಂಕ್ ಹೋಗಿದೆ ಅಲ್ಲಿಗೆ
ಲಿಂಕ್ ಇದು ಬೋರ್ಡ್ ಕರೆಕ್ಟ್ ಇದೆ ಸರ್
ಈ ಕರೆಕ್ಟ್ ಸರ್
ಓಕೆ ಅಲ್ಲ
ಓಕೆ ಸರ್ Good morning to everyone. Today I'm going to give a brief idea about your grammatic analysis. So in previous class also I have given a few examples for you people that how exactly this grammatic analysis can be done by using various steps. So these are a few points which I generally explained in the previous class. So grammatic analysis. So before going to highlight or before going to explain for the steps involved in grammatic analysis, we shall just highlight a few points which we really discussed in the previous class. So what are the points that we covered in the previous class? You know that we have discussed about what exactly grammatic analysis and what are the types of grammatic analysis. So and what is the successful criteria for the recognition or precipitation. So these are the various points we have discussed. Right? In a similar way, as well as we also studied the advantages as well as disadvantages of the grammatic analysis. So in a few points that grammatic analysis, I would like to conclude the things with this. So we can easily use this grammatic analysis for the precipitation reaction. So as you all know, that precipitation reaction is the one. Like the precipitate occurs means when we are going to add a suitable precipitating agent. So then that time we could be able to get the solid material. From that solid material, what we used to get the solid material. So then we are going to use for filtration process. Once if you do filtration, we have to do washing. So after washing, what we have to do, we have to take out that solid sample. Again, solid sample. We have to wash, then we have to keep it for drying for some time. Then we have to ignite. So once it ignites, then also we have to keep it for some room temperature or ambient temperature. Then we can go for weighing purpose. So this is what in general the grammatical analysis involves, right? So again, if we talk about the in the previous class, we talked about the advantages of grammatical. Why one should do this grammatical analysis? Why not others? So this thing also I have explained, right? That the other techniques are also available in the market. So I have example earlier, atomic absorption spectrophotometry. Like we can these things, atomic absorption, integrity coupled plasma mass spectrometry. These are the techniques which we can easily use for the qualitative analysis. If you want to go for a quantitative analysis, means bulk of the solution or bulk of the material, once if you able to find the bulk of the material or in a quantitative manner, we should go for the grammatical method. Of course, in grammatical analysis, there are plenty of methods are there. Electrogrammetry is there. So in electrogrammetry, and name itself indicates electro. By applying current, we are going to deposit some of the particles which is present in the solution upon the electrode. So by depositing the material or particles upon the electrode, by applying current, so this is also one technique of applying electrogrammetry to quantitative measurement. Let it be. So that is also one type of method. But in this particularly grammatical analysis, if we talk about the advantages of this grammatical analysis, so it's grammatical analysis is accurate and precise. Means we used to get very particular, very clean, very neat result we can expect. That grammatical analysis is like potentially more accurate and more precise than volumetric analysis. Because in volumetric analysis, what happens, sometimes we will not be able to see the level of the volume consumed by your solution. Some people like read in a different manner. Suppose if you are able to get like in volumetric analysis. Okay, in this volumetric analysis, what happens? Some people like this curved angle, right? Curved angle. In some cases, what happens? Solution will be down. Yes, this one and this one. There is a difference between these two things, right? So sometimes what we do by reading this one, so for example, this is 23.4. Sometimes we read 23.3. In this also, here the real value of this solution or one is 24.3. Sometimes we may read 24.4, like here. So this difference makes not accurate. Though we may get precise, but if everyone is performing the similar kind of experiment. Okay, so with respect to this volumetric analysis, this grammatical analysis is very accurate because in volumetric analysis, the solution we are there are various things are involved in this one to get the errors in the experiments. So all solution we want to solution we want to go oxidation or we may read very wrongly. So by comparing all these things, we can tell that the volumetric analysis is not much more accurate compared to the grammatical analysis. So this is one thing. And if you talk about another thing, that is possible sources of errors can be checked, like how we can make mistakes or where did we go wrong. These things can easily check in the grammatical analysis. Okay, so that's why the grammatic analysis avoids problems with the temperature fluctuations, calibration errors, and other problems associated with the volumetric analysis. So these are the various steps involved in the advantages of the grammatic analysis. And of course, it is an absolute method. Like gives a particular very exact value. That's why the grammatical analysis has its own advantage. Researchers have given much more attention to the grammatical analysis for the quantitative analysis of any sample. Again, if we talk about one more point of this advantage of grammatical analysis, it is relatively inexpensive. Means it's very easy. We need a simple filter papers and we need some sintered glass filters for filtration and we need beakers. So that and we really don't need any expensive instruments to determine the analyte which is present in the solution. Unlike in the atomic observation spectrophotometry, probably you could see that spectrophotometric instrument in our chemistry laboratory. You can have a look when you enter into the regular classes. So there will be having some kind of filters, papers or filters, like if the monochromatic light is passing through the one filter, that will be reaching to the solution. So that time we'll be able to get the different parameters. The phenomenon takes place. So for that reason, the filter papers or filters are going to call that takes or that is very expensive in nature. So compared with that one, this one, the grammatical analysis is very inexpensive. So these are the various advantages of the grammatical analysis. If we talk about the what disadvantage of this grammatical analysis, there are potential problems with the grammatical analysis that must be avoided. Get good results. And again, one is proper lab technique is very critical. Like if you are not maintaining the proper lab equipments for this grammatical analysis, so that time it would be like not good for getting the good results. So again, careful and time consuming. Of course, sometimes while adding precipitating agent to the solution, we need to add a drop twice. Now, if I would ask you to put a precipitating agent of 10 ml to your solution to make it as precipitate like this, so that time you should not add your precipitating agent of 10 ml completely. Rather, you should add very drop only. You should add drop only with vigorous stirring. So then only precipitation takes place. So this is the one disadvantage of this method of grammatical analysis. Again, we need a clean glass vessel. If we have any impurities on the glass vessel, that is what happens. The impurity also will be there in the final solution or final analyte. So that time we may end up with a wrong results. So this is also one disadvantage of this method. Again, very accurate weighing is must required for this grammatical analysis. So that time we should be very careful about the weighing balance, whether weighing balance is calibrated or not. So this is the one we need to have a look on the weighing balance. So then again, other disadvantages, the co-precipitation. Co-precipitation in the sense what happens, some of the soluble compounds, soluble, what are the things which is soluble in your solution, that will be removed. So that is also one disadvantage of this method. Okay, of this all things, the disadvantages of the grammatical analysis. So in the next step, we will talk about how exactly this precipitation process takes place. This is the one general question that definitely we all have: how precipitation occurs, right? So let us see that one. And before going to precipitate, what are the properties of precipitate? We should understand. Properties in the sense, not all your light is going to get precipitate. Not all solutions we going to give your precipitate or precipitation. There is some set of properties are there. What are those properties? The precipitate should be so insoluble that no significant loss occurs during filtration and washing. This is the first property of the precipitate. I repeat once again, the precipitate should be so insoluble that no significant loss occurs during filtration and washing process. Again, physical nature of the precipitate should be such that it can be easily separated by filtration. If you are not able to get the easy filtration, if you are not performing easy filtration, so that time we cannot tell that there is a very good having a good property of the precipitate. So that reason what the precipitate should be stable and atmospheric condition. It should not decompose when we keep it in the outside or at the room temperature. So this is also one properties of the precipitate. So then the precipitate must be converted into pure compound of one defined definite composition, either by ignition or by simple chemical operations such as evaporations. Like we can easily convert from to pure compounds to definite composition by either by ignition or by simple chemical evaporation such as by simply the atmosphere. So these are also one properties of the precipitate. Again, this precipitate, what we are going to make, that should have a larger crystals, large crystal in the sense, larger particles. Particles, the greater the number of particles or the size of the particle really gives a precipitate very quickly, and upon keeping for some time, that itself will take a reorganize or reorientation to different shape. The one which will be giving a shape, that's the name we are going to give it as a crystals. Again, again one more property of this precipitate is should be free of contaminants. It should not have any impurities. It should not contain any other foreign ions. Foreigners, like some other unwanted things should not be present. So these are the various properties of the your precipitate. So these are the various things of grammatical analysis to make a precipitate. These are the properties should have. Clear? Again, if we talk about the particle size, how exactly this particle size, what exactly this affects the particle size, what made this particle size to act to get the precipitate. So this is the one thing, right? So that's why the particle size and filterability of precipitate means like precipitate made up of large particles are generally desirable in grammatical because large particles are easy to filter and wash free of impurities. In addition, such precipitates are usually pure than precipitates made up of fine particles. So that's why the particle size is very important to get the precipitate. As well as we can easily filter also. If particle size is more or the particle size it is very small, what happens we are taking the precipitate. Okay. If the particle size is very large, what happens? The particles will sit over here. If the particle size is very small, that will be percolated. That will be percolated in the sense they will be easily passed through this filter paper. So that's why basically we expect that the particle size should be in a very large amount. If you are getting the particle size is more, so that time filtration can be easily done. If particle size is very small, so that time like we could not able to find very good filtration. Again, I told you that if you talk about the three types of precipitates are produced, what are those three types? Precipitates. Again, there are some few based on their appearance, we could give the name for those precipitates. So one is this one, so types of precipitates. So one is crystalline, one is crystalline, second one is dirty, and the third one is gelatinous. So these are the three types of precipitates, namely crystalline, dirty, gelatinous. Crystalline in the sense I have an example that will be crystals. Like if you touch that fine crystals, you may feel that something percolating to your skin or very sharp things. If you touch knife, on the tip of the knife, we feel something like very sharp this one, right? So like that we used to feel in the crystalline precipitates. In crystalline precipitate, it looks like, as you all know, that card, right? It exactly looks like card only. That is crystalline precipitate. The final one is gelatinous. It is like somewhat of jelly kind of thing. So these are the various types of your precipitates. So based on their uh, physical identity, so we could give the name for this precipitates. That is, one is crystalline, and another is curly, and the third one is gelatinous. Again, so now the question comes: how this process of precipitation takes place? That is very important, right? So here in this precipitation, basically what happens, it is a most important step in grammatical analysis. Most important, because without this precipitate, we could not able to get final solid product. If no solid, there is no any weighing. No weighing means no gravity like that. So gravimetry is itself indicates that gravimetry. Metry means measurement. Gravi means weigh. You have to weigh something, right? To weigh or to get some solid product, presentation is must. So that's why it is the most important step in the gravimetry analysis. Again, it involves both physical and chemical processes. The physical process consists of three steps. Okay. So before that, the important step in the analysis, and it includes both chemical and physical processes. Chemical and physical processes. Especially if we talk about physical processes, it involves again three steps. It involves in physical steps, three steps. One is especially we talk about the physical process. One is nucleation, and the second one is first one is supersaturation, second one is nucleation, and the third one is crystallization. Supersaturation, nucleation, the third one is crystallization. So these are the three physical steps involved in the precipitation process. Now let us study what exactly is supersaturation, what exactly nucleation, what is crystal growth. Try to remember in your grammatical analysis, precipitation process is very important. Okay, so in order to get the precipitate, there are two methods. One is chemical process as well as physical process. In physical process, again, we could see the three steps. That is supersaturation, nucleation, and crystal growth. In supersaturation, what happens? Like the analyte or the solute will be present in a more number. What I can tell in the simple way is the solution phase contains more dissolved salt than at equilibrium. The driving force will be for the system to approach equilibrium. This saturation. Got it? So saturation means what? In this supersaturation, we can find the more dissolved salt, excess. Say for example, take 10 ml water and take 10 gram of sugar. Mix together. Once it is mixed together, what happens? You can find the clear solution. But when you add excess of sugar to the 10 ml water only, so that time what happens? Some of blurry kind of things appears. blur kind of thing. Means there is no clear solution. That indicates what? You can easily say that there are more number of particles or there are more number of salt is present than required to become a clear solution. Now what it? So this is called supersaturation. I repeat once again, in supersaturation what happens? The more number of dissolved solvent will be present than excess than the equilibrium mode. Hope you got my point. Okay, so in supersaturation, the solution phase contains more dissolved salt than equilibrium. And second one is nucleation. Nucleation. What happens in nucleation? In nucleation, initial phase of precipitation. This one is what? Nucleation is the initial phase of precipitation. A minimum number of particles will gather together to form a nucleus of particle or precipitate, that is solid phase. Higher degree of supersaturation, the greater rate of nucleation. In simple word, what I can tell, in nucleation, what happens, the more number of particles will gather together to form a nucleus of particles or precipitate. So this is what nucleation. And the third one is crystal growth. In this crystal growth, name itself indicates growing takes place of what? The particle enlargement process. Particle enlargement process. Nucleus will grow by deposition of particles of precipitate onto the nucleus and forming a crystal of a specific geometric shape. So this is how the crystal growth phenomenon takes place in your precipitation reaction. So these are the three various types of the physical process. One is supersaturation, and another is nucleation, and third one is the crystal growth. These three steps really use to make a solution to precipitate. So this is clear for everyone. What is supersaturation? What is nucleation? What is crystal growth? Supersaturation is the one you can find more number of dissolved salt, and nucleation is the one. This is the initial step of the precipitation. So in nucleation, the more number of particles or minimum number of particles will gather together to form precipitate, that is solid form. And the third one is crystal growth. Here the particles will grow in such a way that to form a specific geometric shape. What we used to get in this precipitation, right, in the second step, they arrange by themselves for a different shape. By their different shape, they will give some shape. Based on that shape, we can call it as a, that step is called as a crystal growth. Okay, this is three phenomena are very important as part of your examination point of view. So they may ask in your examination how precipitation process takes place for 5 marks. So that time you should write these things. Why precipitation is important in grammatical analysis? What are the steps involved in this grammatical analysis or precipitation reaction? One is physical and chemical. So in physical, there are 3 steps involved. That is supersaturation, nucleation, crystal growth. So these are the 3 steps involved in the precipitation reaction of physical method. This is physical process. Remember that. Next. So once we talk about the how precipitation reaction takes place, like how precipitation reaction takes place. Next, we will take about the precipitation process. So the scientist von Neumann equation. Von Neumann. What this von Neumann equation tells about precipitation process? Let us see. So von Neumann is a scientist discovered that the particle size of precipitate is inversely proportional to the relative supersaturation of the solution. So during the precipitation process, like the particle size of precipitate is particle size of the precipitate is inversely proportional to the relative supersaturation of the solution. Relative supersaturation of the during the precipitation process. During precipitation process. So this is what the von Neumann scientist has discovered, that what the particle size of precipitate is inversely proportional to the relative supersaturation of the solution during the precipitation process. This is inversely proportional. Means what? Like, if the particle size is very small, what happens at that time? The precipitate might not be get very in a good number or good manner. If the particle size is very big, so that time you could get easily the solid product. So that's why the particle size is small. The particle size is very small, that time the product is very less. If the particle size is very large, product is large, means more the particle size. Or in terms of, if you talk about the supersaturation, supersaturation already given the definition for the supersaturation is the more dissolved will be there. So the particle size of precipitate is inversely proportional to the relative supersaturation. If the supersaturation is low, precipitation is, like we can call it as a during the precipitation process. Okay. So again, if we talk about a measure of relative supersaturation or supersaturation ratio, if high means get excessive nucleation. Excessive nucleation means lots of small crystals or large surface area we can find. If low, the precipitation is low means get larger or fewer crystals, small surface area. So this is how the one Neumann has given some equation based on this precipitation process. Clear? So these are the various things of this precipitation process that one Neumann has given. So again, that one term or one equation has given by this one Neumann. That equation is equal to that relative supersaturation. Relative supersaturation. Relative supersaturation is equal to Q minus S divided by S. So try to remember this equation. Q minus S divided by S. That is, von Neumann has discovered this equation. That is, relative supersaturation is equal to Q minus S divided by S. Now let us see what this Q minus S divided by S. If this equation, like especially this equation, the Q is the concentration of the solid at any instant. Okay, S is its equilibrium solubility. So try to remember. So as I told that Q is the concentration of the solubility. Q is the concentration of the solid. S is the solubility. S is the solubility, that is equilibrium solubility. So when Q minus S divided by S is large. When Q minus S divided by S is large, the precipitate tends to be colloidal. The precipitate tends to colloidal. When Q minus S is small, when Q minus S is small, a crystalline solid is more likely. Or crystalline solid will be occurred. So this is what actually one by one equation given about the relative supersaturation. So what exactly this relative supersaturation tells? That we need to understand, right? The particle size of a precipitate is influenced by the experimental variables as precipitate solubility and its temperature and the reactant concentration and the rate at which reactants are mixed. So the particle size is related to a single property of a system, or it is related to supersaturation. Clear? So I will once again what exactly this relative supersaturation is. The particle size of a precipitate. Like in your precipitation, the particles will be present, right? That particle size is influenced by experimental variables as precipitate solubility. We need to check about the solubility also. If low soluble, that time particle will not be able to find. There is no formation of particles. That's why the experimental variables such as particle solubility, temperature, then reactant concentration, and the rate at which reactants are mixed. Okay. So overall, this one is we can gather to take it as the particle size is related to a single property of the system. Is called relative supersaturation. So in that, Q minus S has been given by the one Neumann scientist that when Q minus S is very low, so that time we can find the crystalline solid. When the Q minus S is large, precipitate tends to be colloidal. So again, Q is the concentration of the solution at any instant, and S is the equilibrium, its equilibrium solubility. So this is how actually relative supersaturation can be defined by the von Neumann. Okay, so these all things comes under the category of precipitation process only. Okay, so now if we talk about how your the blue precipitates form, precipitate, like what is the minimum criteria that how precipitation takes place, if we really look into that particular parameters. The precipitates form in two ways. One is by nucleation and by particle growth. The particle size of a freshly formed precipitate is determined by which way is faster. Right? As I told you, the precipitate is going to get formed by nucleation and by particle growth. So these are the two things we need to remember to like how we can get the precipitate like that. Again, if we talk about the nucleation, so as I told, nucleation means a few ions, atoms or molecules come together to form a solid, stable solid form. So often these nuclei form on the surface of suspended solid contaminants such as dust particles. Further precipitation then involves a competition between additional nucleation and growth of existing nuclei. If nucleation phenomenon predominates, a precipitate containing a large number of small particles result. If growth predominates, a smaller number of large particles is produced. This is how we can expect there is a formation of the precipitation. So these are the three steps that I have already explained. One is the supersaturation, the nucleation, and the extreme growth. So these are the three things we need to remember for this precipitation, like how precipitation easily occurs. Okay. Again, if we talk about the purity of precipitate, like what once if we get the precipitation or precipitate, next step is to find out the purity. Purity of precipitate. So when the precipitate is separated out from solution, it is always not preferably pure and may be contaminated even after washing also. So the amount of impurities depends on the nature of the precipitate and condition of precipitate. So it may be due to the co-precipitation, it may be due to the post-precipitation or surface absorption and mixed crystal formation, as well as occlusion and mechanical entrapment. So these are the various steps involved to find out the the purity of the our precipitate. So among all these steps, like how exactly this impurities may be present is. So there are I told you the steps involved in one is co-precipitation. Co-precipitation, and the other one is the post-precipitation. Post-precipitation and mixed crystal formation. And the final steps involve the occlusion and mechanical entrapments. Occlusion and mechanical entrapment. So these are the various steps that that impurities might be present depending upon the of these various steps. That one is the co-precipitation and the post-precipitation. The third one is the mixed crystal formation, as well as the final one is occlusion and mechanical entrapment. Okay. So if we really talk about the co-precipitation, like how exactly the impurities will be present in the precipitate, one is first one is co-precipitation. One is co-precipitation. Co-precipitation is the phenomenon in which soluble compounds are removed from solution during precipitate formation. I repeat, co-precipitation is the phenomenon in which soluble compounds are removed from solution during precipitation formation. So again, there are four types of we can find the co-precipitation types. One is surface absorption, mixed crystal formation, as well as the occlusion and mechanical entrapment. So these are the four various types of the co-precipitation reaction. If you talk about surface absorption and mixed crystal formation are equilibrium process, whereas occlusion and mechanical entrapment arises from the kinetics of crystal growth. Clear? So in this one, we'll look into the main definition of this co-precipitation. We'll try to remember this co-precipitation because in your examination they can ask for 2 marks for this co-precipitation method. So co-precipitation is a phenomenon in which soluble compounds are removed from solution during precipitate formation. Okay. So this is how actually the impurity might be present by the presence of various steps, that is co-precipitation, post-precipitation, mixed crystal formation, and occlusion and mechanical entrapment. So in this today's session, we discuss about the advantages as well as disadvantages of the grammatical analysis. Why the good method is the grammatical analysis for this quantitative analysis we discussed. Again, we discussed about the criteria for the precipitate and how one can be done the precipitation process. Also, we studied, and what are the steps involved in the precipitation process. Also, we studied, and what are the how exactly the purity of the compounds might be measured, or how the impurity will be presented in the precipitate. That also we have studied. So in the next class, we discussed about the further points. Like we discussed about the co-precipitation, right? Next, in the upcoming class, we talk about the more about this purity of precipitate only. followed by the final steps in molecular analysis, like how. Again, we'll give a brief idea about the steps involved in this one. In those steps, we can find these theories that we studied in. If you have any doubts regarding these points that we studied in this today's class, you please feel free to ask in group. We will be able to answer for your questions. Thank you.